Welcome everyone, I introduce myself. I am Alessandro Roveri and in this video I will present my research activity on the design of innovative control algorithms for grid-tied power converters. I am an industrial PhD student and my PhD is funded by the company Prima Electro SPA. To date, my research activity has led to the publication of 2 journal papers and 4 conference papers in the field of control of power converters connected to the grid. I was the co-supervisor from the company side of 2 master thesis students and, in addition, I'm co-inventor of 2 national patents. The first patent has been filed, while the second one is currently being filed. Finally, since 2018, I've been employed at Prima Electro as an R&D engineer. My PhD activity is related to the international context where the electricity demand is increasing worldwide due to the energy transition in key sectors such as building, industry and transportation. This demand gap will be met in the future by increasing the generation from renewable energy sources such as PV and wind power. Both the generators and the load are and will be connected to the grid through static converters. It means a reduction in percentage of synchronous generators connected to the grid with subsequent low power system inertia and grid stability issues. A current example of issue related to low power system inertia is the Spanish blackout of April 2025. A possible solution is enabling grid-tied static converters to perform grid supporting, thus assisting the grid by providing the so-called ancillary services normally in charge to synchronous generators. Ancillary services are the following: primary frequency and voltage regulation, inertial support, fault current injection, harmonic compensation, and islanding capabilities. A promising solution consists in making grid-tied inverters able to behave as conventional synchronous generators, thus providing the full spectrum of grid ancillary services by implementing into the inverter control unit a virtual synchronous machine algorithm. Another possibility, which allows providing the harmonic compensation ancillary services, consists in installing a particular category of grid-tied inverter in parallel to a distorted load. These inverters, named active power filters, are able to cancel the harmonic distortion of the nonlinear load, thus making the grid current and consequently the voltage sinusoidal at unit power factor. This figure shows the APF installed in Prima Electro facility. Summarizing, the goal of my research activity consists in designing control strategies for grid-tied inverters to enable them to provide ancillary services and supporting the grid. I identified 4 main topics that I focused on during my 3 years of PhD. Power decoupling method for VSMs, online grid impedance estimation through VSMs, dedicated pulse width modulations for active power filters, and self-filter design procedure for active power filters. All these solutions have been implemented in industrial products. I want also to highlight that since my PhD is an industrial PhD, my activity has focused on developing solutions that improve the reliability and field performance of grid-tied inverters in industrial applications. In this presentation, I have decided to focus on the estimation of grid impedance using VSMs, as this topic is of high industrial relevance for proper operation of VSMs on field and has also resulted in the filing of a national patent. Let's introduce the topic. Grid impedance affects the operation of all grid-tied converters, not only the VSM-driven inverters. Moreover, it varies with the inverter connection point to the grid, so this is a critical aspect for industrial applications. Furthermore, in VSMs, grid impedance influences the maximum power transfer capability and the local stability, and the tuning of VSM main features such as the mechanical emulation block and the excitation control. Finally, no grid impedance estimation method using VSMs are available in the literature. Therefore, we decided to design a dedicated closed-loop integral estimator for grid impedance computation through VSMs. The estimator consists in the blue block, the orange block, and the red block that are integrated into the conventional VSM model. The estimator inherently rejects the noise, it is fully tunable in terms of time duration and filtering capability, it is simple in implementation, and requires limited computational burden. This slide shows the experimental results. It demonstrates how small current perturbation introduced by the VSMs, together with the enabling of the estimator, allow measuring the grid inductance and resistance with very low relative errors. And the final consideration, this estimator is patented under the Italian patent law. It's time for the conclusion. VSM-driven inverters and active power filters enable power electronics to fully or partially provide grid ancillary services, normally in charge to synchronous generators of conventional thermal power plants. Enabling static converters to perform grid support make them more grid-friendly rather than a problem for the grid. Here reported my main contributions to the literature for VSMs and active power filters. Thank you for your attention.